Let's talk about the special matrices in MATLAB. These are matrices that are automatically created from functions within MATLAB. There are several of them, and we will take a look at 3 of them. We will start with creating matrices of ones. The function is called ones as well. This function creates a matrix with the specified size filled with the number 1. So, ones, open brackets, and here you can see that it takes many different arguments. We will take a look at only a few of them. So, if you want to create a square matrix of 5 by 5, for example, you can use the number 5 once and it will create a square matrix 5 by 5, as you can see. So if you use only one single number, it guesses that you want a square matrix and it will have the same size for both dimensions. If you want, you can also explicitly say 5 by 5. It still creates a 5 by 5 ones matrix. So square ones v2 and square ones v1 was ones of 5. Both of these create the same matrix. If you want to create a different matrix, for example 3 by 5, so 3 by 5 is equal to ones, so you want 3 rows, so 3 and 5 columns like this. Let's run it and we get 3 rows, 5 columns. If you want to create a matrix of ones that is of the same size as another matrix, you can do the following. So ones of same size is equal to ones of the size of this matrix, so of the size of some matrix like this. And if we run it, this is a 3 by 3 matrix, and here we have a 3 by 3 matrix of ones. Now, what if you want a matrix that is not of ones but of some other number? Well, simply add that other number at the time of the creation of the ones matrix, like this. So, if we want these ones of same size to be not of ones but of fives, for example, we can multiply by 5 and we get a matrix of 5s. If you want it of something else, multiply by 8. Since this matrix is only of ones, whatever you multiply by 1, you will get that number. Now, there are a few other ways to do the same thing, so I will show you 2 other ways. The second way is to extract the number in a variable, so desired number equals to 8. And you can say, alright, so now we want some new matrix equals to, and here you will do something interesting. We haven't done anything like this before. We will use the number itself, so desired number, and we will open brackets, so we will use the number itself as a function, and we will say ones of the size of some matrix, and close all of the brackets. Let's run it, and we get the same result. Now, the third way, I'm going to move this number up here and do it like this. So, the third way is pretty much a derivative of the first way. You simply, so some new matrix v2, you simply first create the ones matrix, so ones of size of some matrix, and you multiply it on the next row. So I'm going to suppress this one and multiply it on the next row. So some matrix v2 equals to some new matrix v2 times desired number, like this. So it will produce the same result. So like I said, this is pretty much a derivative of this one. We are just breaking down this one. Now, all of these 3 ways, as we see, produce the exact same result, but one of them is faster than the others. If you want to create a matrix that is of different number than 1, you should use the first way, this way. This way works the fastest from all of the other ways, so you will notice this if you want to create some very large matrix like 10,000 by 10,000 elements. This is where you will notice a difference in the speed. This is the fastest way and also will eat up the least RAM while your script is running. The next matrix is the I matrix or the identity matrix. You have zeros everywhere and ones on the diagonal. So this is created by the I function. So diagonal matrix V1 I of 5. This function works the exact same way as the ones. So if we give it a 5, it will create a 5 by 5 matrix. Let's suppress these matrices first. Alright, let's run it. And we get a 5 by 5 with ones on the diagonal. If you want to create a different diagonal matrix, I 3 by 6, you will get this. Now, just like with our diag function that we use to extract diagonals, this function starts from the main diagonal and creates a diagonal along the main diagonal. So everything else will be zeros. And of course, you can create a diagonal, an identity matrix of the same size as another matrix, like this. Let's run it. There it is. Similarly, you can create a diagonal matrix of non-ones or some other number simply by multiplying it by a number. So diagonal non-1 equals to I of the size of some matrix multiplied by 5. So we'll get a diagonal of 5s. And finally, you can use the identity matrix to extract the diagonal of another matrix. So here our main matrix has a diagonal of 1, 2, and 5. So if we want to extract that diagonal, we know how to extract diagonals, but if we use the diag function, we will extract the diagonal in a vector. And we want to simply extract it in another matrix. The way to do this is to simply say new diagonal equals the matrix or some matrix element by element multiplication with an identity matrix. So I size of that same matrix, like this. And if we run it, we get 1, 2, and 5. The same values that we have for our diagonal. All of these approaches apply to creating vectors as well. You can also create vectors of ones by using the ones function. You will simply need to specify one of the sizes as 1, depending on whether you want a row vector or a column vector. So ones of 1 and 5, you get a vector row. Ones of 5 and 1, you get a vector column.